This is Unit 13, Nuclear Chemistry, Lesson 2, Half-Lives. How are radioactive half-lives determined? The objectives of this lesson, I can calculate, given two of the three variables, the amount remaining, the fraction remaining, the half-life, the number of half-lives, the original mass of radioactive isotope, or the time elapsed. So do now. So a half-life is determined as the time it takes for half of the atoms of a radioisotope to decay. So for example, if I have 100% of a radioactive isotope, the time it takes for half of that radioactive isotope to decay is a half-life. And then the time for half of that to decay is the second half-life, and the time for half of that to decay is the third half-life. So to calculate half-life, we know that after one half-life, 50% or one half of the radioactive element is still present. We know that after two half-lives, 25% or one quarter of the radioactive isotope element is still present. And we know after three half-lives, that 12.5% or 1/8 the radioactive element is still present. And this continues forever. The number will never actually get to zero. We'll always have a little bit left. The half-lives are listed for our selected radioisotopes on table N. So here's what a graph looks like, and we actually will do that in a lab. So it curves down like this, and it will go forever. So table N has your half-life times. They are listed here for our selected radioisotopes, their half-life. The shorter the half-life of an isotope, the less stable it is. And the longer the half-life of an isotope, the more stable it is. So how does changing the temperature impact the half-life? So you should see that there's no effect on temperature for the half-life because it doesn't have to do with temperature. So here are some half-life problems. For example, the amount remaining. If a sample of iodine-131 has an original mass of 52 grams, what mass will remain after 40 days? So the first step is to determine the number of half-lives that have taken place using table N. The second step is to cut the original mass in half by the number of half-lives. So the total time elapsed is the 40 days. The number of the half-life is 8 days from table N. So the total number of half-lives is 5. So I will cut my mass in half. So I start at 52, and I will cut it in half 5 times. So 52 to 26 is 1 half-life. 26 to 13 is 2 half-lives. 13 to 6.5 is 3. 6.5 to 3.25 is 4. And then 3.25 to 1.625 is 5 half-lives. So 1.62 grams of iodine-131 will remain after 40 days. So if a sample of cesium-137 has an original mass of 52 grams, what mass will remain after 150 years? So this is our total time. If we look on table N, we'll see that the half-life of cesium-137 is 30 years. So 150 divided by 30 is 5 half-lives. So if I start with the same mass, so here's my starting point. So label your arrows. 1 half-life is 26. 2 half-lives is 13. 3 half-lives is 6.5. 4 is 3.25. And 5 is 1.63. So after 150 years, there will be 1.63 grams of cesium-137 remaining. Example 2, fraction remaining. So if a sample of cesium-137 has an original mass of 52 grams, what fraction will remain after 150 years? So we know the same thing. 150 years is our total time. 30 years is the half-life, so that's 5 half-lives. So if I were to cut 1 gram in half, that would 5 times, that would get me 1/32. So the fraction remaining is 1/32. So if a sample of iron-53 has an original mass of 52 grams, what fraction will remain after 25.5 minutes? So the first thing is to take our total time and divide it by the half-life found on table N. So that's 3 half-lives. So if I start with 1 half-life would leave me half. 2 half-lives would leave me a quarter, and 3 half-lives would leave me 1/8. So after 25.5 minutes, 1/8 of iron-53 remains. The number of half-lives can easily be determined by how many half-life periods will it take for 50 grams of technetium-99 to decay to 6.25 grams. So first, find the number of half-lives by halving the original mass until you get to the final mass. So if I start with 50, one half-life would be 25, two half-lives would be 12.5, and three half-lives would be 6.25, and that's what I have left. So this is 3 half-lives. So how many half-life periods will it take for 100 grams of iodine-131 to decay to 25 grams? So start with 100. Decay once is 1 half-life. Decay twice is 25. So it will take 2 half-life periods. Example, half-life. What is the half-life of a 500-gram sample of a radioactive element if 125 grams remains after 20 hours? So first, find the number of half-lives by having the original mass until you get to the final mass. So 500 once, twice will get me to that final mass. This is how much remains. So 2 half-lives have occurred. So I have 20 hours, so that's my total time. I know the total time is 20. The half-life from table N is what I'm looking for, so that equals 2 half-lives. So 20 divided by 2 equals 10 hours is my half-life period. So what's the original mass? So the half-life of technetium-99, which is used in brain tumors, is 6 hours. If 10 micrograms are left after 24 hours, how much was administered to the patient originally? So first, divide the times to obtain your amount of half-life periods. So 24 hours divided by 6 hours is 4 half-life periods. Then what I will do is work backwards and double the mass 4 times. So if I have 10 left over, if I double it once, that's 20. If I double it twice, that's 40. I double it 3 times, that's 80. And I double it 4 times, that's 160. That's my 4 half-life periods, and the original mass was 160 micrograms. So after 37 hours, 2 grams remain from a sample of K42. How much was in the original sample? So I have a total of 37 hours. I can get 12.36 from table N, so that's the half-life. So 3 half-life periods occurred. So if I ended with 2 grams, I work backwards once, twice, 3 times to get my total of 16 grams. My original mass was 16 grams. The example, time elapsed. How long will it take for a 40-gram sample of P32 to decay to 50 grams? First, find the half-lives by dividing the original mass in half until it hits your final mass. So I started with 400 and I ended with 50. So that's 3 half-lives. 2, look up the half-lives on table N and multiply that time by the number of half-lives you calculated. So that's the total time. So if I had 3 half-lives, time 14.3 days is 1 half-life. I have a total of 42.9 days. So remember, you only have mass, you never have time. So here's a practice example for you. I won't talk you through it. You can just read through and copy it. Here's another practice example. I won't read through. You can just copy it. And here's a third practice. And now check your understanding. So now you can calculate, given 2 of the 3 variables, the amount remaining, the fraction remaining, the half-life, the number of half-lives, the original mass of a radioactive isotope, or the time elapsed.